Hilchos Kiddush Hachodesh Perek Chamisha Asar. The laws of sanctifying the new month, chapter 15. Again, as we say every chapter, we have to remember where we're heading. We're trying to figure out whether we're going to be able to see the moon on the night of the sighting. And the way to figure that out is to figure out how far the sun and the moon are from each other. And that will tell you if after sunset, you're going to have enough time to see the new moon. Because only if the moon has gotten sufficiently distant from the sun will you be able to see the new moon. In order to know the position of the sun and the moon, you have to know what the Rambam calls the true position of the sun and the moon. Because while the sun and the moon both orbit the earth in the Torah's geocentric model, the orbit is off-center relative to the earth. And therefore, from earth, the sun will be seen at a different point than you might see it if you were standing in the center of the sun's orbit. And the same thing for the moon. We began to learn yesterday that the moon's orbit is quite complicated. And the way that Rambam described it, as we see on the screen, there's two simultaneous orbits. The entirety, the moon is turning on a small circle, the epicycle, that small blue circle. The moon is taking a walk around that circle. But then that whole circle is taking a walk around the earth. So that even if I know where this point, the middle of the orbit is relative to earth, but I have to actually figure out where is the moon on this little circle. So ultimately what has to happen is, and that's going to happen at the end of today's chapter, ultimately what has to happen is we need to find the adjustment or the distance between the middle of the circle and where the moon is on the circle. Like we did with the sun, we made an adjustment for where you would see it from earth versus where you would see it from the center of the sun's orbit. The Rambam just gave us that table of adjustments. At the end of this chapter, the Rambam is going to give us the table of adjustments to figure out, depending on where the moon is on this circle, how much it has to be adjusted from this line. In other words, the distance between the white line and the blue line. The Rambam is going to give us that table today at the end of the chapter. But what's been happening yesterday and will happen in the beginning of today's chapter is that before you can make the adjustment between the two, between the white and the blue line, you have to adjust the white line relative to itself, and you have to adjust the blue line relative to itself. So the white line we adjusted relative to itself yesterday. As the Rambam said, because every day sunset is at a different point. So I can't just tell you where the white line, where the middle point of the moon's orbit will be at 6 p.m. because 6 p.m. isn't always sunset. So depending on the year, you have to add or subtract a little bit, and that will give you what the Rambam called the Emtza Hayareach L'Shas Hari'iyah, the point of the moon's orbit at the time of sighting. Today, in the beginning of the chapter, the Rambam says there also needs to be an adjustment to the moon on this little circle. In other words, even if you know that on the night of sighting, let's say the moon on this little circle is at 10 degrees, let's just call it for example, okay? The moon is at 10 degrees on the little epicycle. There's an adjustment that has to be made to that before you can go on to adjusting the blue to the white. The blue itself needs to be adjusted. Saying now I'm talking about the blue circle itself. Just the moon's little walk on the epicycle. That itself needs to be adjusted. Even if you know that it's at 10 degrees, actually, for the purposes of calculation, you have to add a little bit. Why? What's the reason for this correction? The Rambam doesn't say. And this has become a subject of huge commentary among the Rambam's Mefarshim. It's very unclear. Some commentaries even write it's below tam. There's no reason. We don't know the reason why this correction has to be made. Today, with modern science, we can appreciate it more based on gravity. At the beginning of the month, because the moon is so close to the sun, the gravitational pull that the sun holds over the moon can disturb its regular rate of progress. So even if I know, for example, that on the epicycle, and the Rambam told us this yesterday, on the epicycle the moon is making 13 degrees of progress per day from east to west, clockwise. At the beginning of the month, because the sun is right next to the moon, and it's to the west of the moon, right? Because the moon gets further east from the sun, so the sun is to the west of the moon. The sun is actually pulling the moon more westward. So that even if on a regular day, the moon could make 13 degrees of westward progress, in the beginning of the month, when it's still close to the sun, it's going to make a little more progress. Because of the gravitational pull. That's the way I'm explaining it to you today. Again, the commentaries talk about this at length, and they give different reasons.
One more time. So everything is moving the sun is moving from east to west.
No, the sun on its own is moving. We're only concerned with their own movement. The sun is moving from west to east. The moon has caught up to it,
right,
gotten past it towards the east,
And the sun
which means that the sun is now to the west of the moon, but the sun is pulling the moon back.
Right.
Now, the moon's epicycle is also going east to west,
Right.
towards the sun.
Right.
And if the sun is pulling it, it's going to go even more towards the sun.
Right.
Now, since this disturbance is based on the distance between the sun and the moon, we're saying the sun is pulling the moon. So the way to make this correction, you would think, logical way to make the correction would be to find the position of the sun, find the position of the moon, and because it's the sun that's influencing the moon, the distance between the two will tell you how much disturbance is being created. If they're still very close, there's more disturbance. If they're further, there's less disturbance. But that's not the way that Rambam describes it. The Rambam in the beginning of this chapter tells us that the way to determine this correction is to find the distance between the sun and the moon and then to double the distance. And based on the double distance, that's how you'll know how to correct the disturbance. Why? So again, it's not relevant to the Rambam directly. The Rambam doesn't give us reasons, but just to be able to appreciate it a little bit and to give us a headache, let's try to get into it a little bit. Okay, and I'm going to use a little bit of a primitive diagram to explain this. So please bear with me. In the picture here, the moon's orbit, the general big circle, seems to be centered to the Earth. Right? The Earth is in the center of the moon's orbit. Mathematically, it's okay to say that. But in truth, the moon's orbit, as the commentaries explain it, is also off-center. So take a look here. Okay, I know it's a lot of lines and circles going on over here, but just take a look for a second. All the dotted lines, that's what we're going to focus on first. All the dotted lines are the universe in molad position, when the sun and the moon have met. If you want to see it a little bit better in a diagram, look at this, okay? This is molad position. You have the sun, the moon. The moon is at the very top of its little circle. It's aligned with the sun. The middle of the orbit and the entirety of Earth, it's all aligned. Okay? Going back, that's what the dotted lines. Earth is the black dot in the center, this black dot. That's the moon's orbit, the big dotted line. That's the moon's epicycle, the small dotted line. That's the sun, the smallest dotted circle. And you can see that everything is aligned. Now, what actually happens, as the Mefarshim explain it, is that the entirety, after one day, let's go to the proper lines, the entirety of the moon's orbit has moved to the west, 11 degrees. And the small epicycle has moved 24 degrees east. I know yesterday we said the progress is 13 degrees, but as the commentaries explain it, this is really what it is. It's a combination of two motions. It's a combination of the fact that the entirety of the moon's orbit has moved to the west 11 degrees, and the moon's little epicycle has moved 24 degrees. 24 minus 11 is 13. That's why the net progress, we call it 13. But in reality, it's a combination of two simultaneous motions, 24 this way, 11 this way. If you do the math, at the end of every month, the two will meet again. That's why when you speak in simple terms, you just talk about the moon's orbit being centered relative to the Earth, because mathematically, since every month it all meets, so those differences don't really matter. But in the beginning of the month, when the separation is first happening, let's call it after a day, you can see that we're on the dotted line in molad position. This was the apogee of the moon's orbit, the furthest point from Earth. Now, after day one, this is the furthest point of the moon's orbit. And again, in 30 days, it's going to come right back. But for this day, it's over here. And the moon has moved over here. The entirety of the epicycle has moved. But because the entirety of the big orbit has moved, the little circle, the epicycle, also moves kind of down. You see, even if it's going to make progress this way, but it also goes a little bit down out of that original circle because of that.
Wait, one more time. The apogee and the next point you said?
So after a day, whereas by molad position, the apogee of the moon's orbit was here, it moves 11 degrees to the right the next day, the apogee of the moon's orbit.
Okay.
And at the same time, the entire little epicycle is moving along the orbit to the east, 24 degrees. But because the entire big circle has moved, it also disturbs a little bit of where the small circle has moved. Right?
Right.
So now, this I don't even understand myself because I'm not big on trigonometry. But trigonometrically speaking, whenever you have one circle that's off-center relative to the other, okay, so you have the Earth in the middle, the big Galgala Mazalot, and the moon's orbit is off-centered. Whenever you have a an off-centered circle, let's call this the actual center of the moon's orbit. Yeah, this is the center of the dotted line. This is Earth. This is the center of the moon's orbit. If you draw a line from Earth the other way to the equidistant point, in other words, let's just call it for argument's sake, yeah, the center of the moon's orbit is 10 feet away from Earth on this side. So if you draw a line 10 feet this way, this point right here, trigonometrically, I don't know the principles of how it works, but if you draw a line from here through the Emtza HaYareach and continuing, you will reach the angle of the disturbance. That's just how it works. So to put it on a better diagram, this is the Moiled position. Everything is aligned. This is 1 day later. Okay, this is the sun. The Gova, the apogee of the moon, has moved 11 degrees this way. The Emtza HaYareach has moved 13 degrees in total this way. That little dot is the center of the moon's orbit. This little dot is the equidistant point. By drawing a line from the equidistant point all through the Emtza HaYareach through to the moon's epicycle, we get that little difference right here, that little difference of disturbance.
So there is a difference.
So there is a difference. But that's why the Rambam speaks about it in terms of doubling the distance between the sun and the moon. Because when you figure out that double distance, you're able to reach the equidistant point across the Earth relative to the off-center of the moon's orbit, and then draw a line from there through the Emtza HaYareach and reach the angle of disturbance. So it's just the method. The reason why the Rambam chooses this way is because that's the mathematical way to arrive at the disturbance. If we had the Rambam's tables, we don't need to do this whole headache. All we need to do is find the difference between the sun and the moon, and that's it. Based on how close they are, we'll know how the gravitational pull affects it. But if you're doing the math behind it, you have to first double the distance, find that point, draw the line, and then come up with the disturbance. That's why the Rambam does it in that way. Now, by the way, just one point that I forgot to mention, the reason why it's double the distance is because it's actually double the distance. If the Gova moves 11 degrees this way, and the Emtza HaYareach moves 13 degrees this way, the sun also moves 1 degree to the east. So you're going to have exactly 12 degrees on each side, between the moon's apogee and the sun, and between the sun and the moon's orbit. That's why it actually fits to call it double the distance. But again, in terms of the moon, the Rambam is doubling the distance so that we can appreciate the trigonometric way that we arrive at the angle of this disturbance. Okay? That's the math behind it. Now let's just forget everything we just said, delete it. Let's go back to the basic information.
So we're just doubling the distance, okay?
Exactly. The basic information, the reason why we're doing all of this is to be able to figure out where is the moon actually on its epicycle. Before the correction of the epicycle and the Emtza, before this correction of white and blue, we have to correct the actual blue line. And the actual blue line, again, is being corrected because of this gravitational pull. And the way we figure that out is by that double distance that I just showed you. And that's what the Rambam gives us in the beginning of this chapter. So with that long introduction, let's get into it. Halacha Aleph. Im tirtza leida mekayma yareach ha'amiti b'chol yom shetirtza. If you wish to know the true position of the moon any day you want, toitzi tchila emtza hayareach l'shas ha're'iyah lo'isei alayla shetirtza. You must first ascertain the average position of the moon, as it's adjusted for the time of sighting, as we learned yesterday, for that night. V'chein toitzi emtza ha'maslul. Also figure out where is the moon on its own little epicycle. V'emtza ha'shemesh lo'isei ois. And also figure out where is the sun on its own orbit at that time. V'tigra emtza ha'shemesh me'emtza hayareach. Subtract the position of the sun from the position of the moon. In other words, figure out how far is the moon from the sun, the average position. V'hanishar tichpe lo'isei. And what remains, double it. V'zeo hanikra merchak hakofel. This is called the double distance. The double distance means, again, the distance between the sun and the moon doubled, or in the way we spoke about it, the actual distance between the moon's apogee and the moon and the center of the moon's orbit. Ukvar haidanu, says the Rambam, we've already notified. All we want with these, we're not learning astronomy, we're learning astronomy with a purpose. All the calculations here are to know whether we're going to be able to sight the new moon on the night of the new month. At that point in the month, on this night, which potentially you can see the new moon, it's impossible for this distance to be anywhere less or more than 5 and 62 degrees. It's It's only going to be somewhere between 5 and 62 degrees, no more and no less. Therefore, I'm only going to give you the table for those numbers. And again, the point of this table is to adjust the extra disturbance on the moon's little epicycle. We're just adding to the moon's position on the epicycle. Halacha gimel v'hoyil v'hadavar kein hisbeinin b'merchak zeh hakafel. Since the matter is such that it can only be between 5 and 62, so check out this double distance, and here's what you have to do to correct it. Im yiyeh hamerchak hakafel chamish mailas ekarev l'chamesh. Here, I made a table over here. Where is it? Here. If the distance, again, the double distance is 5 degrees, or around 5, ein chesheshin l'teisefes v'lo teisef klum. They don't have to add anything. Since the sun and the moon are so close, kind of counterintuitively, the gravitational pull doesn't disturb it as much, because it's already so close. If the distance is between 6 and 11 degrees, you need to make a correction of 1 degree. In other words, if the epicycle's position is 10 degrees, now it's going to be 11. If the distance is between 12 and 18 degrees, add a correction of 2 degrees. If the distance is between 19 and 24 degrees, add a correction of 3 degrees. If the distance is between 25 and 31 degrees, you add the correction of 4 degrees. If the distance is between 32 and 38 degrees, you add a correction of 5 degrees. If the distance is 39 to 45 degrees, add a correction of 6 degrees. If the distance is anywhere between 46 and 51 degrees, you add a correction of 7 degrees. Between 52 and 59 degrees of distance, you have to make a correction of 8 degrees. If the distance is between 60 and 63 degrees, and again, the Rambam means a little less because it has to be about 62 degrees, that's when you make a correction of the full 9 degrees. The position of the moon on the epicycle after you add these corrections, is called the true course. In other words, the moon's true position on its epicycle as it relates to our calculations. And now that you know where the moon truly is on the epicycle, now you can make the adjustment between the Emtza HaYareach and the Emtza HaMaslo. Because now you truly know where the moon is on the little path. And only when you truly know where the moon is on the little path can you make the correction between that and the white line. And that's where the Rambam goes right now. Then you must check out how many degrees is the correct path. In other words, where is the moon on the little epicycle? Here we follow the same principles as the sun. If it's gotten less than 180 degrees from the highest point, from over here, if it's anywhere between here and here on the path, so the adjustment, you will have to subtract the angle that I'm going to give you in a minute from the wherever the middle of the moon's orbit is. Where am I over here? You're going to have to subtract it. In other words, because the moon is going to be seen further back. Right? Anywhere over here, the moon is going to be behind relative to the Galgal HaMazalot. If 0 is here and 30 is here, so if the Emtza HaYareach will be seen at about 15 degrees, because the moon is here, you're going to subtract some of that number, and you're going to reveal that the moon is actually going to be seen at 7 degrees, for example. But if the moon on its epicycle is anywhere between here and here, on the second half from 180 to 360, in this case, you will add the angular adjustment on the Emtza HaYareach because it's going to be seen further down. If the Emtza HaYareach is at, again, 15 degrees, if the moon were here, you would see it at about 30 degrees. And actually, maybe I have a picture of this. I believe I do. Right. If it's on this side, so here you can see. that if the moon is on the second half of the circle, you will have to add some numbers to account for the fact that the moon will be seen at a higher degree.
So one half of the
circle requires subtraction, one requires addition.
So there's always going to be 2 points where it's perfect.
Yes. There's always going to be 2 points where it's perfect.
Even a broken clock is right.
As the Rambam says right now. Whatever the position on the epicycle comes out to be, after you add or subtract these numbers, that's the true position of the moon for the time of sighting. And as we just said, you should know, if the moon is exactly at the top over here, or exactly at the bottom, exactly at 0, or exactly at 180, as we can see over here, for example, the moon would be at the top of the circle. So, there is no angular adjustment. The average position is exactly the true position, because they're both going to be seen in the Galgal Mazalot at the same degree. So now let's get to the actual table. What are the adjustments? How much is the angle that has to be added or subtracted to adjust the distance between the Emtza Hayareach, the middle of the orbit, and the moon's true position? If, after making the earlier correction, the moon is revealed to be 10 degrees on its little epicycle, the adjustment is just 50 minutes, less than a degree. If the moon on the epicycle has a progress of 20 degrees, the adjustment that has to be made is 1 degree and 38 minutes. For 30 degrees of progress, the angular adjustment is 2 degrees, 24 minutes. For 40 degrees of progress, the angular adjustment is 3 degrees, 6 minutes. For 50 degrees of progress, the adjustment is 3 degrees, 44 minutes. For 60 degrees of progress, the adjustment is 4 degrees, 16 minutes. For 70 degrees of progress, the adjustment is 4 degrees and 41 minutes. For 80 degrees of progress, it's simply 5 degrees of adjustment. For 90 degrees of progress, the adjustment is 5 degrees and 5 minutes. For the next slide over here, for 100 degrees of progress, the angular adjustment is 5 degrees, 8 minutes. Now we're going a little more down. If it's 110, the angular adjustment is 4 degrees, 59 minutes. For 120 degrees of progress, the adjustment is 4 degrees, 40 minutes. For 130 degrees of progress, the angular adjustment is 4 degrees and 11 minutes. 140 degrees of progress, the angular adjustment is 3 degrees, 33 minutes. For 150 degrees of progress, it's 2 degrees and 48 minutes of adjustment. For 160 degrees of progress, it's 1 degree, 56 minutes of adjustment. Some texts have over here Maila Achas, but you should delete that. For 170 degrees of progress, the adjustment is only 59 minutes. If it's 180 degrees exactly, there is no angular adjustment, as we said. The point of the average position of the moon is the true position. And the Rambam only goes from 1 to 180, because from 180 to 360, it's the opposite, just backwards.
So one more time. So this whole Nasamaslo thing, that's adjusting
from the perspective of the viewer on Earth, where the moon will actually be. Had I only been going by Emtza Hayareach, so I would see the moon over here. Now that I've adjusted it, now I'm going to see the moon over here. And the adjustment is made based on where the moon is on the little circle.
Right. If it's however many degrees on the circle, that's how many you adjust it from the
middle white point.
So why is it called Menasa Maslo?
Menas means angle.
So
The angle caused by the path. The difference in angle that's caused by the moon's.
The earth caused by it.
Yes. Zayin v'imiyah hamasal hanochin. Yesel al meo shmeinin mailos. If the progress on the moon's little epicycle is more than 180 degrees, tigra oisei mishleish meis v'shishim v'teida manosei. Simply subtract it from 360, and you will know the angle kederech sha'asisa b'masal hashemesh, as you did with the course of the sun. Because again, if the moon is at 350, right over here, 350 is 10 degrees this way, like 10 degrees is that way. So whatever 10 degrees will be this way is the adjustment for 350. And the same goes the opposite.
It's like a mirror image.
Exactly. It's a mirror image. That's a great way to think about it. Similarly, if you have individual units, it's not exactly 130 or 140, it's 135. Simply get the difference between the two angles at the tens. The same way we explain when it comes to the sun and its angles, so too you will do with the course of the moon, the true course of the moon for its angles. You simply just get the difference between, if 130 is this and 140 is that, 135 is halfway in between. And that's it. Now you have the true position of the moon as it's going to be observed from the perspective of somebody on Earth. But of course, we can't end the chapter without a visualization. So the Rambam does it for his own time. Ketzad, halacha ches. How would this look practically? In the other visualizations, the Rambam was going 100 days out to the 14th of Tammuz. Today he goes just 1 month out. We began at 3rd of Nisan. He's going to Thursday night, 2nd of Iyar. The amount of full days that have passed from the night of the starting point till this night, where we want to ascertain the true position of the moon, is 29 days. So first look for where the sun is. The average position will come out to be 35 degrees, 38 minutes, 33 seconds. Where's the moon's average position going to be at the time of sighting of this Thursday night? 53 degrees, 36 minutes, 39 seconds. Now also, where is the moon on the epicycle at this time? The moon on the epicycle is 103 degrees, 21 minutes, 46 seconds. So we can look at the screen here because it's somewhat how the position would look in the Rambam's time. Because again, it's just after the Molad, it's the beginning of the month. The moon is a little distant from the sun. Sun's at about 35 degrees, the Rambam said. The moon is at 53 degrees, a difference of 20. Tigra emtza hashemesh me emtza hayareach. Subtract the position of the sun from the position of the moon. You remain with 17 degrees, 58 minutes, 6 seconds. V'zehu hamerchak, that's the distance between the sun and the moon. Double it, the double distance therefore is 35 degrees, 56 minutes, 12 seconds. Following this table, therefore, you're going to add to the position of the moon on the epicycle 5 degrees, as we've said, because anywhere between 32 and 38 degrees on the table, you add 5 degrees. Here we're at 35 degrees, so you add those 5. So the true position of the moon on its epicycle would be would be 108 degrees instead of 103 and 21 minutes. In this case, we don't care about the minutes, just focus on the degrees. So now we need to figure out the angular adjustment for this position of the moon on the epicycle. Now that we know that it's actually 108 degrees, it's 108, the angular adjustment is 5 degrees and 1 minute. Why is the Rambam saying that? Because over here we learned that for 100 degrees, the top, it's 5 degrees and 8 minutes. For 110 degrees, it's 4 minutes, it's 4 degrees and 59 minutes, for a difference of about 9 minutes. So therefore, per additional degree, you would add 1 additional minute. So for 108 degrees, it's, per additional degree, you would subtract one minute, right? Because at 100, it's 5.8, 110, it's 4.59. So at 108, it's about 5.1. Since it's less than 180, so what do we do with the angle? Tigra hamana. We have to subtract the angle. The moon's going to be seen further back on the Galgal Hamazalot. This 5 degrees in 1 minute, from the position of the moon in its average position. Yishoyer. So what will remain from that? Again, it used to be 53. Now where is it going to be? 48 degrees, 35 minutes, and 39 seconds. Tasa shniyas chelek, convert the seconds into a minute. Add it to the minutes. So where is the true position of the moon? It's actually going to be at 18 degrees, 36 minutes of the 19th degree in the Mazal of Torah. So it's a big difference. It's almost 5 degrees of difference. That's why it's so important to know where the true position of the moon is going to be. And following this method, you can figure out where the moon will truly be at any time of setting that you want. From the beginning of this year, the year of a starting point, till the end of the world, till all of eternity.